All right, today we're going to talk about permutations and combinations. Try and take the time, but go quick all at the same time for you. Okay, so in permutation, here's the difference. In the order matters. That's it. Okay, so often I think of the Olympics, right? First, second, third place. Okay. That means that we're talking about the order or the arrangement of those items. They totally matter. How do we find that on the calculator? So this means we have 5 total objects, right? Or whatever it is. 5 people run a race. The top 2 get a prize. So here's how it works. 5. Tried to preview this the other day. We're going to hit math. I'm going to work backwards over probability and then go down to permutation. I want a permutation of 2. Done deal. So that means this answer is 20. Okay, we'll do that one more time over here. So I'm going to start with the number. Okay, so I have a grand total of 12. It's my total first. 12 has to go in, and then math. I always go backwards. I think it's a little bit faster. On a permutation, we're going to pick 3. So this is 12 runners. The top 3 get a prize. Okay, so that means there are 1,320 ways for that to happen. Okay, so that's what we're talking about, the number of outcomes that can happen. All right, so I'm going to drop the calculator part for a little bit, review those buttons. If you need it, I'm going to keep it off to the side as we work through a little bit. There are 10 finalists in the math competition. So 10, how many ways can gold, silver, bronze? Well, that means we're choosing the top 3. That makes it a permutation. So 10, permutation of 3. That will be 720. So in a class, right, there's 12 students, and we need to put all 12 of them in their seats. So 12 permutation of 12. Well, that's going to be a pretty large number. Okay, so let's just double check it. 12 permutation of all 12. Now this could be done by a factorial as well. So we get 47,900,1600. All right, to double check these, sometimes it's easier just to put some of those commas in there. Now, what's going to happen when we say, actually, you know what? We get 3 additional seats. So now I have 15 seats, but I'm going to seat 12 students. So 15, math, and move to probability, permutation, and this time we're going to seat those same 12 students, but notice what happens, and this is why I wanted to show this one, is we turned into scientific notation. So 2.17, 2.18 times 10 to the 11th. Okay, so we got a little bit larger on here so that the calculator tripped over. I want to make sure I showed you exactly what was happening, that we are dealing with scientific notation when your calculator shows that. All right, Cat Lover has 12 cats. She lines up 4 of them for a creepy cat parade on YouTube. Don't lie, you've seen them before too. All right, how many creepy cat parades are possible? So 12, the order matters for a parade. So we're going to put 4 of them in there, and then we'll get our final answer. It's 11,880. Enjoy. All right, the next thing we're going to deal with is some repetition. Okay, so this happens if we're going to pick the entire group, right? We're going to use everything, but at some point, some of the objects are identical. Okay, this often happens with our first example. So I'll kind of explain it by doing the first example with you. That we're going to spell the word Mississippi, all right, but then once we're done with that, right, we're going to have some fun with it. And how many different ways can the letters in the word Mississippi be arranged? So I have to use all of them. So that gives us our first number. There happen to be 11 numbers. So it's 11 factorial. But then what happens after that is we don't have to make a new word. They just have to be rearranged. So the first thing I do is I look for something and I say, well, what's being repeated? So what's being repeated is the S, 1, 2, 3, 4. So there's a 4 factorial for the S. So I like to keep track of what's going on there. There also happens to be 4 I's in here. So I have those, and there are 2 P's. Okay. So up top I have the grand total. There are 11 letters, and then if anything repeats, so the S repeats 4 times, the I repeats 4 times, and the P repeats 2 times, then we're able to divide all of those back out, as flip-flopping the first S and the second S wouldn't give us any new arrangement. So we have to basically subtract those out. So here's what it looks like. It looks like 11 times 10 times 9 times 8. You get the idea. All right, why did I stop there? So I'm going to stop there. So I have 4 factorial, 4 factorial, and 2 factorial. Okay. Hopefully you didn't write that as quick as I did. I'm going to take my 4 factorial. I'm going to take my 2 factorial and take my other 4 factorial and write this one out. All right, so I stopped at my 4 factorial because I know that I can cross that one out with the top 4 factorial on the bottom. The next thing I want to look for is what else can I get rid of? Well, if I take my 2 times 4, that gives me an 8 I get to get rid of. So this is only if you have to do it by hand. Otherwise, we'd be over on the calculator side doing a whole bunch of stuff. The next thing I notice is that I have 3 times 2 is 6, so I can get rid of that. So my final answer ends up being 11 times 10 times 9 times 7 times 5, and that's it, because it's over 1, so I don't really need those at all. So done correctly, we get 34,650. So that's if it falls onto something where it's non-calculator. Otherwise, you probably would use the right-hand side of the screen, which we're rendering useless right now. So I got some beads, and we're going to put them on a keychain. But if I make the first one red and the second one red, then the arrangement doesn't matter, right? So we're repeating something in there. So this is why it falls into the category that we're in today. So how many are there total? 5, 3, 8, 9, 10. There are 10. And then how many repeat? Well, 5 of them are red, and 3 of them are blue, and 2 of them are green. And you're saying, well, why are we doing this at all? Because it seems like it should get rid of everything, but it doesn't, right? So 10, 9, 8, 7, 6, 5. Here's my 5 factorial. I'm going to get rid of those right away. So on the bottom, I have 3 times 2 times 1 and 2 times 1. All right, so my 3 times 2 times 1, that's going to take out the 6. And the 2, I might just reduce that with the 8 to make it 4. Yeah, I could have used the 10. Either which way, final answer, 2,520 arrangements to make that cute little keychain beaded keychain. What am I even talking about? All right. So we have Skittles, and you're kind of OCD, right? Just like me. That's why we like math so much. Everything adds up. Then before you actually eat them, you're going to line them up. Yeah, seems normal, right? So again, there are 10 of them. 3, 4, 5, 6, 7, 8, 9, 10. All right. So 1 factorial, yeah, there's no repeat there. But 2 factorial, 3 factorial, 4 factorial. So again, 10, 9, 8, 7, 6, 5, 4. I'm going to stop at 4 so I can get rid of my 4 factorials. Come back to 3 times 2 and 2 times 1. If I want to put 1s on there, I can. So I'm going to get rid of 6. And maybe this time I make the 10 into a 5. Totally up to you wherever you go with that. Because at that point, you might be using the calculator for the remainder anyway. So 12,600 becomes your final answer. So anytime we have repeating, we're going to divide those out. So that's all fine and dandy. Last idea, combinations. So first thing is, get the right-hand side of our screen back in play here. If you have 7 of something, we're going to find out how many combinations, because the order didn't matter, right? This was just simply, there's 7 people. I need 2 of you go to the office to pick up some books. I wish, right? It'd be great if we could be back in school and just go down to the office and pick up some books. So we get 21. We got 8. This time there's 8 people, and we ordered a really big pizza because I'm hungry. So I need 5 of you to go down to the office to pick it up. Then we'll have a pizza party. All right, so there are 56 ways to do that because the order doesn't matter. We're just picking a group. Okay, how many ways can a team of 5 be chosen from 11? So always start with the greatest number, the number that we're talking about. There are 11 athletes. We're going to choose 5. Now, you won't get an error message on your calculator if you do it backwards. It's going to tell you that there is, well, let me just show you. So if I happen to say, you know what, I want 5, and I want to do a combination of 11, now notice you can't have a group of 5 and pick 11. So it's just going to tell you 0. There are 0 ways to do that. So if you're getting 0 for all your answers, that means you put it in backwards. Okay? If for this one you actually got 462, that's good. But I just want to make sure I show, sometimes like if we divide by 0, we do something strange like that, it'll tell you undefined. It doesn't tell you that. It tells you there's 0 ways to do it, which is accurate to the question, or, to what you had typed in. So it won't tell you you're completely wrong, but if you're starting to see 0, you're completely wrong, right? All right, so we have 7 campers are attacked by aliens. This happened last week, I think. The aliens, they only choose to abduct 2 of them, and then they leave. How many ways can they choose them? So there's 7. They're going to abduct 2. All right, so that was 21. We had that one up top here. So hopefully you didn't go and do that again. All right, so the last one, this one gets into our probability also a little bit. We have to understand a few things about cards. So 5 cards are drawn from a standard deck of cards. How many hands consist of 3 clubs and 2 diamonds? Okay. So for the clubs and then for the diamonds, get that, that's a good one. All right, so there are 52 cards, which means there are divided up by 4, so there are 13 clubs. So we want 3 clubs, so it's a combination of 3. The order doesn't matter here, right? So we're going to get that answer. And then there are also 13 diamonds. How many do we want? We want 2. Okay, so there's eventually we want to multiply these 2 things together to find out how many combinations of this are possible. So this is where we get kind of to this Algebra 2 idea of combinations, permutations. And it's because we have multiple things at play here. So we have 286 ways to get the clubs. We got 78 ways to get the diamonds. So there happens to be 22,308 ways to get this hand. So it does start to build on itself.